Happy New Year and welcome to the International CES. This is my favorite week of the year. This show promises to be our best in history, with innovation leading the way to an exciting 2011.
Ladies and gentlemen, please welcome Chief Executive Officer, Microsoft Corporation, Steve Ballmer.
Good evening and welcome. 2010 was a very, very exciting year for our customers. We launched Windows Phone 7, Office 2010, and Connect, and we introduced Internet Explorer 9 and Office 365. We saw great growth in our Bing and Azure services. And with the amazing success of Windows 7, it's truly been a year like no other. So we want to start by saying thank you to the over 1 billion customers around the world for their support and feedback. I also want to have a chance to say thanks to all of the folks here in the room and on the webcast for taking the time today. We appreciate your time and your support. With Connect, you are the controller, and there's nothing else like it in the world. Xbox 360, Xbox Live, and Connect have made 2010 the biggest year in Xbox history. We will make entertainment more interactive, more social, and more fun for everyone. And we'll do it like no one else can. So everyone who's enjoying Connect knows that today it listens to your voice and tracks your body. But what about your facial expressions? As you can see, now Connect can track features like your smile, your laugh, and even the raise of your eyebrows. Here's just a little taste of what's next on Connect. We call it Avatar Connect. Maybe it's just me, but that avatar was pretty darn bald, I think. Face recognition, body tracking, now even facial expressions, all coming to your living room. I'm pleased to announce that this spring, Avatar Connect will be made available for free to all Xbox Live Gold members. To our heavy hitter game franchises, all coming to the phone. You've already seen hits like Crackdown or Halo Nation on the Windows Phone 7. Today, I'm excited to announce that Fable is coming to Windows Phone 7. Windows Phone 7 is dramatically different from other phones. We approach the opportunity with a pretty fresh and very unique perspective. We asked a couple of basic questions. First, could we help simplify the tasks that people use their phones for the most? And second, as more applications are released, and as phones can do more than ever, could we still make them easy to use? The result, in my view, was something importantly different. A phone uniquely designed to delight modern-day smartphone customers. By redesigning the fundamental way the phone presents and organizes information, we made it easier and faster for people to get things done, like snapping and sharing a photo, keeping up with friends, family, and those who matter to us personally the most, and figuring out quickly where and what you're supposed to be doing next. In the past few weeks alone, we've added great new titles, like the Kindle, the Bank of America app, the Fruit Ninja game. Today, there are already more than 5,500 applications available for Windows Phone customers, to more than 100 new applications every 24 hours. And more than half our customers download a new application every day. There's one more product that I would like to talk about tonight before we wrap up, and that's the Windows PC. We made some announcements earlier today, and I want to spend some time putting them in context for all of you. A year ago at CES, we talked about how excited we were with customers' early reactions to Windows 7. We had just launched, and all indications were that we had delivered a product that had hit the mark with customers. That really proved to be the case. Windows 7 PCs are the fastest selling PCs in history, selling over 7 copies a second. They now represent more than 20% of all the PCs connected to the internet. A Windows 7 PC is the best possible way and place to experience the modern web.
You remember from the first version, you notice there's some pretty stark differences from version 1 of Surface PC. We worked hand-to-hand with Samsung on the entire end-to-end experience I'm about to show you. The first thing to notice is that the PC is thin. No longer is it a big box with the cameras inside. This is only 4 inches thin. Inside here, there's a full-power Windows 7 PC. It's got a dual-core CPU and a GPU from AMD. Up top, this is the biggest piece of Gorilla Glass that has ever been bonded to an LCD ever. But what's really amazing about this technology, what really makes it magical, is the sensor itself. So those first-generation Surface PCs needed cameras underneath that would look up to try to see what was going on. But what we have here is called Pixel Sense. Pixel Sense is new technology we've invented where there's infrared sensors all across the screen. Every single pixel is actually acting as a camera. The PC, the Surface here, can actually see. So I'm holding up a piece of paper that says I can see, and when I set it down, what you see on this debug monitor and what you can see in the split screen above is that the PC can actually see that paper. So this is even beyond touch. And Pixel Sense is more than just vision. It's actually the processing inside that takes that data and makes it available for developers to write cool applications on it. One of the really cool things about this new thinner form factor is it no longer has to just be a table. You can also use Surface as a kiosk. And I want to talk a little bit about the Royal Bank of Canada. This is one of our launch partners that is going to be putting these Surface PCs in public. These are ruggedized PCs. This thing is designed for industrial commercial application. In fact, if you go across the street to Hard Rock Cafe, you can see some of the Generation 1 Surfaces in use there in the bar. They can take the impact of a beer bottle dropping from 18 inches onto the screen without breaking, and even the fluid will run off properly. But do not tell them I sent you over there to try that. Here's an example of an application that would be up in the bank. The Royal Bank of Canada sends these flyers to thousands of potential customers, and when they take the flyer into the bank, they just show it to the screen, and Surface recognizes the flyer. It can see the flyer and enter you into this drawing and see whether you've won. And that's the power of Pixel Sense technology. Vision-based interaction creates a whole new category of applications that developers can write. You can see in this case I've won, which always happens in my demo. And when I close this, I can interact with some of the other applications that the bank might have to show up some of the products and services that they would have for customers. So here's an example of modeling how their savings products would work. So I save $5 a day, I get a little more realistic interest rate and save it for 20 years and see how it accumulates. So with the new lower price, the smaller size, the more versatile form factor, I think you're going to see Surface PC in a lot of cool places in the next year or two. So Steve, if you want to come back out, you can take a look at what it looks like to have 20 fingers on the screen at the same time here. I like this.
You got 10, I got 10.
There we go. Thanks.
Great. Thanks, Mike. They're on the leading edge of new devices that offer it all without compromise. Earlier today, for the first time, we talked about the next version of Windows. We announced that the next version of Windows will support systems on a chip architectures from Intel, from AMD, and from ARM. This announcement is really all about enabling a new class of hardware and new silicon partners for Windows to bring the widest possible range of form factors to the market. We made the announcement now in order to allow all of our partners to work together and build upon this innovation. Windows has always been and will continue to be about the breadth of hardware and software applications and innovation. We're very excited about the full set of partners for the next version of Windows. NVIDIA, Qualcomm, and Texas Instruments are working on SoC designs based on the ARM architecture. Intel and AMD will continue to innovate on the x86 platform, including the new low-powered SoC systems that will be fully supported by Windows and will include support for native x86 applications. Windows support for SoCs is an important step for Microsoft and for the industry. Increasingly, customers expect the full range of capabilities from any device. The power and breadth of software that is available for today's laptop, the long battery life and always-on capabilities of a mobile phone, great browsing, productivity and media experiences, in addition to the basics, printing, and support for all of the hardware devices and peripherals. Windows has the breadth and depth and the flexibility to define and deliver this next generation of devices to customers through the innovation of our partners.
So we announced earlier today the system-on-chip architecture for the next major version of Windows. And what we did was a technology preview. So while everything out here today is based on Windows 7 and coming soon, what I'm showing you here is a first look at the platform support of the next major version of Windows. Now, we're not showing the new Windows user interface. We're not showing any new Windows features. This is all about platform support today so that partners can start working together on new designs. I'm going to start with an Intel system. And what you're looking at here is Intel's low-power Atom SoC system. Now, before I get started, I want to explain what we've got going on here. This is a kind of development board that we use to do pre-production software and pre-production hardware together. Underneath this heatsink is the actual chip. And the SoC is about this big. And by the time we actually ship, that entire chip fits on a motherboard about this big. So this is the entire motherboard of the PC with the memory, with the slots and everything. The PC doesn't need to be any bigger than this, plus a battery and a screen, and can be of any size. And what we're working on here is an example of what it looks like when we're doing development. Now, this is a future version of Windows. We're running on the low-power Atom SoC architecture from Intel, and what's so cool about this...
Future version of Windows,
future version of Windows.
Current user interface.
Current user interface. This is all about supporting the basic chip level, kind of at the kernel level, if you will. The thing that makes the Intel platform really interesting is the compatibility with all of the existing software and hardware applications that run on Windows today. So what I'm showing you here is a version of Quicken that I just got from the store. Off the shelf, installed it, and it just worked, no modification. The same thing is true when I plug in this Windows 7 phone. You can plug in a camera, printer, anything that works on Windows works right out of the box here. And so a really high level of compatibility. You can see it recognizes the phone and it's going to start syncing. There it goes, it connected the device and recognized it. So all of that's working today. And that's one of the really big benefits of the Intel system. We've also announced today partnerships with 3 more partners that are making ARM-based systems. And I'm going to show you Windows, real Windows client running on ARM. So this is Qualcomm's ARM system called Snapdragon. And this is the Windows client running on ARM. I can pull up the command prompt and show you the version string for the kind of people that track that sort of thing. Just to show that it's real, I've got desktop pinning, I've got accessories launching. You can see I can open my photo library, I've got customization, I can change my desktop background. What I'm showing you here is the Windows desktop up and running live on an ARM system. And that's really the first time. This isn't virtualization, this is Windows running natively on ARM. We're also working with Texas Instruments. This is their ARM platform called OMAP. And what I'm going to show here is an example of how hardware and software applications can work. So I'm going to launch Word and paste in some text and hit print. And what I did there is actually launched Word. That's Word running on ARM. So this is a build of Word that we've recompiled to be a native ARM application. And you saw it launch. You saw that I pasted in some text. And what I have down below me is an off-the-shelf printer from Epson. It's a USB printer. And what we did with them is we recompiled the ARM driver. We recompiled the print driver to run natively on ARM. And in just a moment, you can see that it prints. So that's real. Thank you. That's real office working, that's real print driver working, and the print driver is just one of the subsystems that we have up and running. We can connect to cameras and storage devices and other cool things like that. Now this third ARM system I want to show you is from NVIDIA, and NVIDIA is known for really high performance graphics, and the same is true on their ARM system as well. This is their Tegra platform, and what I'm going to launch here is PowerPoint. So I have another Office application that's launching, and it launches quickly, and you can see I can type into here Windows on ARM, and I can create new slides quickly, and the performance is fast. And that's because PowerPoint is one of the Office applications that takes advantage of hardware acceleration, so you can get smooth transitions between slides and smooth animations. It's running really fast because it's actually hardware accelerated today on the Tegra platform. I also can show you another application that's using hardware acceleration, a next version of IE. So here's Internet Explorer with an HTML5 demo, so you can see how smooth and responsive spinning these pictures around is, and you can see how quickly it responds to the mouse. This is all because the graphics is being processed on the GPU on the ARM chip itself. And performance is really important, especially for things like video. So I'm going to launch the Iron Man trailer, and I'm launching this in HD. This is full HD output, and what you're going to see is smooth, fast-playing video. It doesn't drop frames, it doesn't stutter, it's really high performance. This unit actually even has HDMI out, though it's not connected on this demo. I can jump around to a different frame in the movie and see how quickly it can catch up instantly. And it's playing fast and it's playing smooth. So what you've seen here today is Windows, real Windows, running Office, devices, high-performance browsing, high-performance video, all running on next generation of SoCs.
Super.
Thank you very much.
That's all about today, Mike. Thanks to all of our partners for the fantastic work that they're doing.
Thank you.
Pleasure. Great. Wish you a wonderful new year and absolutely a fantastic CES. It's been my pleasure.